right, Chapter 8, Section 2, Algebra 2, Reciprocal Function Family. All right, so we're all familiar with the standard equation of a linear function, y equals mx plus b, where m is your slope, x is your x coordinate, y is your y coordinate, right? Well, what if we had the reciprocal or the inverse of x, right? What is the inverse of anything, right? It's where you switch roles. Whatever is in the denominator is in the numerator, whatever is in the numerator is in the denominator, and when you multiply it, you get the number one. And we have reciprocal functions. So the reciprocal of a linear function is this: y equals a times 1 over x. This is not a linear function, so this a doesn't represent slope, but it does represent some type of manipulation of this function. Notice that since x is in the denominator now, there's certain things that x can't be. And x can't be anything that turns the denominator into 0. In this case, x can't be 0. Reason being is that you cannot divide by 0. You cannot divide by 0, so x can't equal 0. So this is our reciprocal function or inverse function. When you graph our inverse function, I actually want to take a look at it a little bit more. So y equals a 1 over x. When you graph this, right, since x can't be 0, we're going to have an asymptote, in this case at 0. All right. So when we're graphing this, here's our x-axis, here's our y. As this gets smaller and smaller and smaller and closer to 0, we won't be able to touch the x-axis. It won't exist. If we have an asymptote of x, is there any type of asymptote for y? And the answer is yes. Y can also not equal 0 in this case. And the reason being is, let's look for an example. If we had y equals 0, we have a times 1 over x. Well, I multiply both sides by x, right, to make x in the numerator. What I do on one side, I do to the other. What's x times 0? Well, it's 0. 0 equals a? That's not possible. So since I have some type of contradiction, it does not exist. So when I graph this, as this graph gets closer and closer to a, or y axis is going to go up. As this graph on the other side, in the negative, same thing. Where we have the asymptote at the y-axis in this case, and the asymptote at the x-axis. Right. This is what an inverse function looks like. Okay. It's generally in the form of y equals a over x minus h plus k, where x can't equal h because then we get a 0. And we're going to find out that y can't equal k is either, because that's not possible, because that makes y 0. So that is our generalized inverse. So we're going to get into the h and the k and the translations of it, and a as well in a moment. All right, so down here they ask us to graph this function y equals 12 over x. So we're going to do it for two scenarios. What happens when x is a positive number, and what happens when x is a negative number. So we're going to have two cases. Actually, I'll do it like this. Alright. So here would be a negative, so let's go -1 to be -12, -2, -6, -3, -4, -4, -3, -6, -2, -12, -1, let's say -24. And that's -1/2. Ran out of space. I guess I should put them side by side. Oh well, I learned my lesson. So let's do it positive numbers. So 1, 12, 2, 6, 3, 4, 4, 3, 6, 2, 12, 1, 24, 1/2, 36, 1/3, right, and so on and so forth. As the number gets bigger and bigger and bigger, y gets closer and closer and closer to 0, but it's never going to cross 0. Same thing here. As x gets more negative and negative and negative, this number gets really, really smaller and closer to 0. So y gets closer and closer to 0. As y gets bigger and bigger and bigger, if we look in the reverse, let's look at the y. If y gets bigger and bigger and bigger with the positive numbers, x gets really, really close to 0, but it's never going to go to 0. Same thing over here. As negative y gets, or the absolute value of negative y gets bigger and bigger and bigger, negative x gets closer and closer to 0, but it never reaches 0. So when we graph this, this is where we get our asymptote. Again, as it gets closer and closer and closer to 0, y equals 0, as x gets smaller and smaller and smaller. Or bigger, sorry. As x gets smaller and smaller and smaller, y gets bigger and bigger and bigger and close to 0. As x gets bigger and bigger and bigger, it gets closer to the x-axis. Alright, so we have an asymptote at the x-axis, we have an asymptote on the y-axis. So, and let me repeat that. As x gets smaller and smaller and smaller, y gets bigger and bigger and bigger. So as x goes to 0, y gets really, really big. As x gets really, really big, y gets really, really close to 0, but it's not going to cross. Or, and vice versa for the negatives. Okay. If I have a 6 over x or 8 over x or 12 over x, they're all going to be similar functions. They're going to have the same asymptotes. When it's like this, also to note, y equals 12 over x, there is no y-intercept. It doesn't cross the y-axis. So no y-intercept. And it doesn't cross the x-axis either, so there's no x-intercept. Remember, y-intercept is y when x is 0. In this case, x can't be 0. Y is x when the x-intercept is x when y is 0. Well, y can't be 0, so there's no y and there's no x-intercept. Okay. So what happens to these graphs when a changes? So for part 1, we have a is equal to 1/2. So if we was to graph this, let's see, it's 1 over x. So y equals 1/2 over x. I'm going to rename this because we're not going to have a fraction that looks like that. It's going to be 1/2 times 1 over x. All right. The parent graph is y equals 1 over x. So if we were to graph y equals 1 over x, it would look like this. And this is what happens when we have a. In this case, a is 1 here, but let's have a equal to 1/2. Let's look what happens. It shrinks. It compresses a little bit. It goes down. What happens when a is 2? So it's going to be y equals 2 over x. Well, let's take a look-see. So here's our original y equals 1 over x. This is our y equals 1/2. Here's our y equals 2 over x. It stretches, right? Here it compresses as you go from 1 to 1/2. Here it stretches as you go from 1 to 2. So what happens? I'm going to take a look at the 1/2. The next scenario gives us what happens when a is equal to negative 1/2. So y is equal to negative 1/2 times 1 over x. Well, let's take a look at that. Switches. It goes over the x-axis. The curve in green gets flipped, reflected over the x-axis, and it goes this way. Curve in green, reflected over the x-axis, and it goes this way. So, a few things. Thing number 1. If a is greater than 1, the absolute value of a is greater than 1, then it's going to stretch. If the absolute value of a is less than 1 and greater than 0, then it's going to shrink. And if a is negative, then it's going to reflect off the x-axis. So reflect, whatever. Reflect off the x-axis. Or you can say switch to. Okay. So those are the A's. That's how the transformations happen with the A's. Alright. And that's noted here. Yeah, that is how you spell reflect. I can spell. Alright. Absolute value of a is greater than 1, it's going to stretch. Absolute value of a between 0 and 1 is going to shrink. If a is negative, it's going to reflect off the x-axis or switch off the x-axis. So that's shrinking and compressing and stuff. What happens if we have our standard form? So this is our standard inverse reciprocal equation, 1 over x minus h plus k. Okay. In this case, remember x cannot equal h. If x equals h, that's the vertical asymptote. If y equals k, when y equals k, that's your horizontal asymptote. Okay. X equals h is your vertical asymptote. Y equals k is your horizontal asymptote. And remember, that's the part where the graph cannot cross. All right. If I was to have a h, it would if h is positive, it shifts to the right. If h is negative, shifts to the left. If k is positive, shifts up. If k is negative, it shifts down. Okay. All right. What's the graph of this guy? Okay. And what's the domain and range? Okay. For the range, it's going to be all real numbers except 4. Because if x equals 4, then it does not exist. I'm sorry, that's the domain. Range, my y's, this is going to be all real numbers except 6. Because if y was 6, subtract 6 from both sides, so y equals 0 doesn't exist. All right. If I was to graph this, just eyeballing it, I have an asymptote, a vertical asymptote at 4. So 1, 2, 3, 4. This would be my vertical asymptote. And I have a horizontal asymptote at 6. 1, 2, 3, 4, 5, 6. Right. So if I was to graph this guy, it would look like this at the asymptotes. Okay, it would look like that at the asymptotes. And let's see that. Okay. So there is 6 right there. Matter of fact, I can add that in here. Y equals 6. And let's add x equals, was it 4? X equals 4. Alright. So as you can see, horizontal asymptote at 6, it's never going to cross 6. Vertical asymptote at 4, it's never going to cross 4. Okay, so you can base your graph off of that. The asymptotes tells you where to go. Here it says, what is the function of the graph translated at the right? The parent function is y equals 2 over x. So if I look at this guy, I'm just going to look at the asymptotes. So this is 2 and 4. This looks like that's halfway, so that's 1. So it has a vertical asymptote at x equals 1. And it looks like I have a horizontal asymptote at y equals negative 4. So when I put this in, remember it's going to be in the form of y equals a over x minus h plus k. So remember h is the vertical asymptote. So when x equals h, that's our asymptote. So this is going to be my h. This is going to be my k. So this is going to be y equals, the a is 2. So 2 over x minus 1, because that's my vertical asymptote. And I have a negative 4, minus 4. Y equals 2 minus 1, minus 4. 2 over x minus 1 over 4, minus 4. Y equals 2 over x minus 1, minus 4. All right, so this is going to use an inverse function to solve. So we have 325 people. They're renting a facility for laser tag. It costs $1,200. You must have 13 adults. And as a chaperone, so they're not going to pay. And they wanted to make sure that everybody pays $750. That's the minimum cost, so that's my cost. Everybody pays $750. How many students would I need at $750 to pay for this particular event? This event seats 325 people, but of those 325, 13 are adults. So I'm going to subtract 13 from 325, and I get 312. So I have 312 students. The first question asked is how many students must attend to make it. Who can, with respect to the number of n, what's the domain of the function? Okay, so the domain of the function is going to be between 0. So we're going to say n for the number of students. So n is going to be less than 312 and greater than 0, right? Between 0 and 312 kitties can attend this function. I want to pay $750 per student. It costs $1,200 for the whole event over the number of students that I have. I don't know what I'm going to say for students. I don't know what that is. All right. So, how many students would I need to make 750 a possibility? So here's the deal. I can multiply, but I can do this algebraically. Multiply both sides by n, divide by 750, and I can get that n is equal to 160 students. So I need at least 160 students out of this 312 to attend so that I can make everybody pay 750 to cover the event. So a little bit more than half. We can also solve this graphically. So I have y equals 1200 over x, or n in this case. And for our ticket price, 750, we go y equals 750. Here's my y equals 750, and I can see where they intersect. And lo and behold, for $750, or $7.50. I need 160 students. That's where they intersect. So you can actually solve this graphically, or you can solve it algebraically. They then say that they're going to give away 30 tickets. I'm just going to give it away. How many students will you need to cover the cost now? Okay, so instead of 312, we're giving away 30. So that's 302, 292, 282. So we're now, instead of 312, we now have 282. All right, so in this case, we have between 0 and 282 students can attend this event. This equation changes because we're giving 30 away out of the 325. We account for that right here. N minus 30. There's 30 tickets that we're not going to use, or we're going to use, but we're not going to charge for. So we're taking that away. N minus 30. How many students can go now? How many students do I need now to still keep the 750 cost? Well, if I do the math and etc., I get that n is equal to 190. But this is a little misleading because it's now not n for number of students, it's number of students minus 30. So if n equals 90, then n minus 30 still equals 160. So really, it's still 160 students. I need 160 students paying $750 to still cost $1,200. And the reason why I can do that is because if I take away 30, I still have 282 tickets left to, which is greater than 160. All right, so I can still give away 30 and still charge $750 and still be okay. I still break even. So that does work. So it's not going to be n, it's going to be n minus 30. And it's n minus 30 to get me 160. Graphically, if we saw the intersection, it would intersect at n equals 190 because it's solving for n. But again, remember, we're not solving for n, we're solving for n minus 30. So it's still 160 students that's needed for this to break even. Okay, that's this section. I hope you have a great rest of your day.